Quick question for you.
Yes.
I understand that when you do training, you
Yep.
always carry a phone book with you. Why is that?
Yeah, so you saw my phone book tour. So Tim and I just had a client recently, and one of his clients doing some performance tuning with, and I actually made the client search low and high to find a phone book, which for some of you people watching the video, you might not know what a phone book is. I mean, do your kids know what a phone book is?
They know that it comes every 6 months or a year,
Yeah.
but they wouldn't know how to use it.
Yeah. So the phone book, it's a white pages, or in yellow pages, you look up last names in it. I don't always bring a phone book. I bring a phone book sometimes when I teach a certain class, but there's two concepts, and these could all be really complex. But there's two concepts when it comes to query tuning. There's indexing, and there's what's called sargability, or some people will say sargeability. Like maybe Jonathan Cahias would say sargeability.
Probably.
But sargability is it comes from the word search, or the words search argument.
Mm-hmm.
So what a search argument is, it's a query that's formed in such a way that an index can properly answer it. So select star, don't say select star ever. So that's just my example. So
Select column 1.
select column n, or n's, columns n, from phone book table, where last name equals Mitchell. That's a sargable query. That means if there's an index on last name, which is what the phone book is, it's a clustered index on last name, you'll end up finding that data through the index. And now there's other things that maybe you will prevent you, but for all intents and purposes, and for the purpose of this, it's going to work to sort of help you find the query. So I bring the phone book with me because when I do like a basic SQL tuning class, an indexing class, people ask, well, what if I write a query like this? What if I write a query like that? What if I use a function? What if I use a like query? And the answer, it's really basic. It's kind of silly, but I like concrete examples when I teach, so it can sink in people's head. But I'll pass the phone book around the room, and I'll ask people to look things up. So I'll give you a phone book and say, show me every single person's phone number whose last name contains the characters I am next to each other. So in SQL, that would be select last name, comma, phone number from phone book, where last name like, open single quote percent, I am percent.
Looking for it in the middle of the name.
Yep, a contain search.
Yep.
And I say, here's a phone book. Find me all the last names that contain I am. And some people, because it's a weird, I'm telling them to do something, and they're supposed to just be sitting there like this, watching and pretending to pay attention or check email or whatever. So there's like a pause, and then half the time they start opening the phone book and say, oh, and then they stop and say, oh, wait a second, I can't, and they'll give it back to me and say, that's impossible. And it's not impossible. You can sit
It's
there.
just time consuming.
Here's a piece of paper. Go into a corner, and 4 days later you can have all the phone numbers.
Right.
But what that illustrates to them is a sargability. I didn't ask them a sargable query. I didn't ask them a search argument. A better word almost could be seek argument, because that argument is not used for a seek. I've asked them to do a scan. And then I use the phone book to illustrate cluster indexes versus non-cluster, and the concept of covering indexes. And I'll say like functions. Like, if we had a function that took an input of a last name and output an integer, and the integer was the number of syllables in that last name. So, function syllable finder Mitchell would be Mitchell, right? 2. So it'd be 2. I didn't do that. I did that because I just had to think about it in my head. That's just, but 2. So 2 for Mitchell. So if I said run this function on every single last name in the phone book and tell me all the last names, that the answer would be 3, 4. So find me all the 3-syllable last names for this function. And I give them the phone book again, they can't do that because the function is non-deterministic. SQL Server doesn't have function-based indexes.
So they have to go name by name by name to figure out, does this match or does it not
Evaluate
match?
the function and ask does it match. Evaluate the function, does it match. So that's another great example of why that doesn't happen. And then that story leads into why implicit conversion kills people. And that kills so many people's queries, because you have a varchar or varchar, or do you want to say it, depending on where you're from, or varchar or varchar. Or
Varchar. It's varchar or nothing.
It is, but it's a character, not a char. So why would you say char? It's not a character.
I'm reading it like it's written.
Yeah, see, and I say varchar, so I guess we can't be friends anymore. But I'm half joking. So if you have a varchar in the table and your parameter is an n varchar, that's an implicit conversion. So that implicit conversion is making your index search do a function, and that's why the index can't be used. And there's exceptions to every single rule when it comes to query tuning, but the phone book just makes it brings alive tuning. You said it was a quick question. Sorry, it's a long answer, but I tell people, think of the phone book. So when I leave, I say, I say, think of the phone book and write your queries. Now is that a great advanced SQL tuning tip? Not really, but I'll still think of the phone book sometimes. So here's another example. If I gave you that contain search, and I give you one big phone book and said, find all the last names that contain IM, you're going to hate me for that, right? But if I just took the phone book open and ripped out 2 or 3 pages and gave it to you, all right, I can do that. It stinks, but it's doable.
Yeah.
So the point there is,
it's a lot of work on a smaller set of data.
Yeah, a contain search isn't bad.
Right.
But a contain search on your entire customers table, when you have 2 million, a contain search on Equifax's customer table.
Oh.
They have
the secure or the not secure data?
Because obviously we know they have at least 140 million records. But that contain search is a long time. But if you just take a list of the people who weren't impacted, which is probably a smaller list, that
6 or 7.
That contain search is quicker. So
Right.
so that's the point. I don't mean to make light of identity theft. It's not funny. And it's going to be a pain in the butt for us and for the company. But the point, though, is a contain search on a smaller set of data is quicker. So if you can minimize that data set sooner through temp tables or through sort of good joins and filtering, and once you get a smaller data set, now it's easier to do contain search. So that one phone book illustrates a lot of lessons. At least I hope it does. Maybe people think I'm crazy. But,
Yeah, that makes sense. All right, thanks for that.
no, thank you. Good question. Do you bring any props to classes?
Do I bring props? I'll bring candy. And
yeah.
I threw out candy. So my last time that I did a presentation, a full day presentation, normally I'll throw out candy.
Nice.
I forgot to bring my candy, but I had allergies at the time, so I'm carrying cough drops. So I'm offering to throw Hall's cough drops at everybody.
Well, your eyes are red and your nose is
Yeah, they
sniffling.
didn't want me to throw anything at
Did
them.
anybody
at that
take any
point.
cough drops from you?
Nobody took up. Yeah.
Does anybody want any cough drops? No, Tim, we don't even want you teaching us. Yeah, nice. That's
Yeah,
funny.
that's it for me.
Yeah, cool. Thanks for the question.
All right, thanks. That was good.
Thanks.